Okay, hello everyone. It is time to get started with this week's studio review video. This week we learned about a very important concept called methods. We're going to be using methods a lot to perform abstractions, basically allow us to apply a name to a certain behavior that we would like to repeat over and over again throughout our code. So they start us off by having us take a look at the distance between method. And the way that we declare methods is by starting off with a couple of magic words. We're going to talk a lot more about what these words mean when we get to Module 7. But for now, you can kind of treat them as some magic words that we need at the beginning of every method definition. The next thing that we see here is called the return type. This tells us what the method is going to be giving back to us. So this method is going to be returning a double value. Next, this is the name of the method, distance between. Should hopefully be clear and describe exactly what's happening. And then finally, inside of the parentheses here is our list of parameters. So this could be empty, it could just be an empty list of parentheses. In this case, we have 4 parameters separated by commas, where each parameter has a type and a name associated with it, much like variables have types and names. So these are the inputs into our method, and the idea is that if we give you 2 xy coordinates, x1, y1, x2, y2, this method will compute and return, or output, the distance between those 2 points. So it is our task to write the code that'll go ahead and set that up. It's probably going to be something like distance is equal to math.square root of x1 minus x2 squared, right? Math.pow can be used to square this by supplying an exponent of 2. And then it's going to be zip plus math.pow y1 minus y2, which will also be squared. Make sure our parentheses are okay. This is a somewhat complicated line of code. You can see it's a little bit long, but you know, the distance formula is something that I expect most people have seen before, so hopefully it's pretty straightforward what's going on here. If you wanted to break this down into pieces, that would certainly be okay. Let's go ahead and test our work. The way that we typically do that is using something called unit tests. So we actually supplied you with some unit tests here, and we're going to go ahead and run those as our JUnit tests, and I want to show you what that looks like once that's done. So here we can see that for the distance between tests that have been written, I see some green check marks by the first few. That means that they have successfully completed, and those green check marks are an indication that this method is working the way that we would expect. But let's take a look at these and see what's actually happening here. Unit test consists of making an assertion, where that assertion is going to say that, for these given values, this is what I expect the answer to be. So you can see that for the first test that's given here, it's testing that the distance between 1 and 2 is around 1. The way to interpret this is that, here you see that we are calling the method distance between with the specified x and y values as explained in the comment. This is the value that we expect to get back of 1. And then this value over here is a tolerance. It's basically allowing there to be a little bit of a fudge factor, right? A little bit of a, if you're off by that much, we'll still count it as being okay. There's some other tests that use different points to make sure that our method is, doing its job. And the important thing to realize here is that our method is really only as good as the tests can demonstrate that it is. So just because one test passes doesn't mean that this method is bulletproof. You can think of, there might be very easy ways to, trick this test into thinking that the method is working even though it really doesn't. So in order to make sure that the method works the way that we expect, one test is really not sufficient. We have to test the method under many different conditions. The more the better, the more tests we have that pass, the more confident we can be in the way that our method works. And then sometimes you'll run into situations like this last test here, test points D, where we can see that it's trying to test the distance between 0, 0 and 30, 40. But if you look, there's a mistake. The way that the parameters are passed in, the order of these matters. So it's supposed to go x1, y1, x2, y2, and x1 is 0, y1 is 0, but we see that it's actually got both of the x values first, followed by the y values. So the order's mixed up. If we fix that, now our test should, be testing the thing that we said it's testing, right? Let's rerun our test by clicking this button to make sure that that is in fact the case. Okay, now we see that yes, all of these do in fact pass. So we fixed the test, but this is another important takeaway here, which is to remember that human beings write these tests, and as all things human, we have the tendency to make mistakes. So unit tests are great to help us make sure that our code does what it says it does, but we also have to remember that tests can be wrong, and we also have to remember that tests by themselves are not really useful. If we have a lot of well-written functional tests, then we can confidently say that our code, our method does what it says it's supposed to do. The fewer tests that we have, or if there are significant errors in our tests, then of course they're not useful to us. So like using a broken hammer, for example, you'd have a hard time building a house. So it's important to make sure that you take the time to verify the correctness of your tests as well as the correctness of your code. And if you get further into software development, you'll spend a lot more time learning how to write these tests. For now, though, I think that we've fixed the tests that were broken. I believe that they, let's see here. Yeah, we did that. Oh yeah, they want us to add another test. So let's talk about how to do that briefly before we move on to the next problem. So we're going to make a method. Each test that shows up over here is just a method in this file. And so you'll see that the way that we set this method up looks a little bit different. In particular, that word static is missing. But we can ignore that for now and just kind of plug along. They want us to write a test for the case that the distance between 8, 9, and 5, 5 is 5. So actually, I'm just going to go ahead and grab, this, and just tweak the values. I would imagine this is probably similar to what your group would have done. So 8, what were the 2 points? 8, 9, and 5, 5. All right. 9, whoops, and 5. I believe that'll do it. Hopefully if we run this, we'll see this test show up and tell us that it's also functional, but let's see here. We see, okay, actually no, it does not. And the reason for that is because we forgot this little magic word right here. This tells Java that the method is actually used for testing purposes and not just a regular old method. So once we add that little annotation to the top, we can rerun our tests once more. This time, test point E shows up, and it passes, so that's good. I think it's supposed to be test points E. There we go. Great. So as programmers, it's not just our job to write code that works, but it's also our job to make sure that we can demonstrate that it works. People are not perfect. We need to have some assurances that our code is doing what it says it's going to do, and unit testing is one tool that we use for that purpose. So you'll continue to see unit testing as we go along. You can use them as a tool to help you on the homework assignments coming up this week and in following weeks for that matter. All right, let's move on to the next method. This time we're going to write a method to draw a bullseye on the screen. So we saw how to use the graphics library last week with standard draw. This time we want to use a method to draw a bullseye for us, and if we think about why that might be useful, consider that I can draw a bullseye in many different locations with many different sizes, but the overall ratio of the circles remains the same. So if we have a method that takes in a position and a size of our bullseye, we should be able to scale our drawing accordingly and place it at the appropriate spot on the screen. This makes it a much more useful tool than a program that just draws one bullseye and then I have to change the numbers every time I want to move it somewhere else or change the size. We now have a method that makes it very easy for us to customize our bullseyes. So let's go ahead and take a look at the starter code that's been provided for us. Here we go. Draw a bullseye is the name of the method. The parameters that are coming in are x and y, which is the center of the bullseye. The radius is going to be the total radius. And the comments here suggest some colors that we can use for each of the circles, but also tell us each of the sizes. So a blue ring, all right. First, let's make our color. Color blue equals new color 0, 109, 219. Okay, use the colors specified there. We need to import that value or import that color package. So let's go ahead and do that. Then we'll set our pen color. Blue. And then we'll draw our circle. Where we want it to go at the XY position, but we want the radius to be 3/4 of the radius. So let's do that. And before we move on, we can actually test this with the little debug app and see if we've got the first part working properly. Let's go ahead and run this and see what happens. See if we get some bullseyes. All right, there I see the black with the blue. Let's continue on and see black and blue, smaller in a different spot, right? Looks like it's working. Let's continue on and add the other colors in. I'm actually just going to copy this chunk of code and replace it with the appropriate colors. So this time we're going to want 146. And you don't have to use the exact colors here. Of course, you could use your own colors if you want to. It's going to be red. This time we're going to do 1/2 of the radius. And then for the last one, the yellow ring, use the suggested color. And this time we'll do 1/4 of the radius. All right, let's run that debug app one more time here and see if we have accomplished our goal. That looks like a bullseye to me, and if we continue, we'll see the bullseyes dancing around the screen, drawing them in different places. Hopefully you can understand how we are able to use this code, right, to draw all of those bullseyes. And hopefully you see the value in having, this is basically a blueprint on how to draw a bullseye at any position for any given size, correct? And so that's a much more useful tool than the way that we would have done things before, with everything in the main method having to specify exactly where all the bullseyes are. And how big they are, etc., etc. Okay, on to the next. Yes, this is quite a tricky problem. Substitute all is the next problem on our to-do list. So first thing I think that's important to understand is exactly what substitute all is doing for us. So the idea here is that we have some word that we're looking for, some text, some target letter in the word, and we're going to replace that target with whatever this replacement word is. So if I sketch out a little example here, right? If I wanted to replace the word hello, find all of the letter L's, right, and replace that with the word hi, then the result that I would get would be he, hi, hi-o, right? This would be the result that I would expect to get back out. It's going to locate all of the L's that exist in the original word and replace them with this value. So our task then, if we think about this, if I go through all of the letters that exist in the original word, then I'm basically asking the question, okay, does this match what I'm looking for? If it doesn't, then I can just pass this on. If it does, though, then I'm going to pass this on instead, the replacement word. So if we try to turn that into code, right, we need to have a way of accessing all of the letters in our string. And so using CareAt is probably the best way that we can do this. You can use this toCarArray method if you prefer. I think that's sort of an alternative solution. But I'm going to use CareAt. I'll show you how to work that. It's very much like iterating through an array, where instead of iterating through an array, we're going to use the string here, string.length. Oh, whoops. My mistake. And now inside of this if statement, we can simply retrieve a character using source.CareAt I. So the first time through, this will get us the character position 0, which will be the H, the E, the L, or whatever the letters are for the word that's being done in this particular example. So if we know that's the case, then we'll just pass. I just want to take that character and pass it on to our result, which I could do by calling this method again, although actually I think it'd be a little simpler to store it in a letter, store it in a variable. So let me create a variable for this. If I'm grabbing one letter from a string, that's actually a different type. So here's a type that we have not seen too much before. It's called a char, or a character. You can think of a string as being an array of characters, actually. All right, so now I can say if the letter is equal to target, so we've found a match, then my result will simply concatenate on the replacement word, which is called replacement. Otherwise, so we know that it doesn't match the target letter, we'll just concatenate on the original letter. So I believe this will do it, but just to kind of remind you how this code is working, this loop is going to iterate through once for each letter, once for each character in the source string. This line here retrieves the letter at the given position I and stores that in a variable. We then proceed to check to see if that letter is equal to the one that we're looking for. If it is, then we'll replace it with the replacement word. If it is not equal to the target letter that we're looking for, then we'll just pass that letter on to the result and leave it alone. Then at the end, we'll simply return our result. Let's go ahead and take a moment to run our tests to make sure that this code passes. All right, substitute all tests do appear to all pass, so that's good. This is one of the trickier methods of the studio, so be sure to look through that one again if you're still a little unsure how it works, and make sure you understand exactly what's happening. If you saw this using the CareArray method, that's fine too. That's a perfectly good solution as well. They want us to take a look at the tests here. All right, we see R is a R is a R is a R, and then we substitute the word rose in for R. It says rose is a rose is a rose. That makes sense, right? But now we're going to substitute in a couple times. We're going to substitute the word beauty in for the letter B. But then when we try to substitute in the word truth for the letter T, you see that we actually get a double substitution, right? Notice that this is only performing one substitution per trip through the method. So if you want to perform two substitutions, you have to be a little bit careful. You have to be a little bit careful about how you perform it. It's a little bit of foreshadowing for you for the next homework assignment. All right, let's continue on to our next method, which is the ArraySum method. So we've seen up until now that we can use all kinds of different types for our parameters, but we've seen arrays in the past, and we would like to continue using those. So let's see an example of how we can use arrays with methods as well. The idea behind this method is you can see that here I'm taking in an integer array of values, and I want to just go through that array and compute the sum of all of those values. This is a pretty straightforward problem. I think that we maybe have even asked you to solve something similar to this before, or if not, you know, you can see I'm going through this solution rather quickly. I don't think this should be a terribly difficult solution for you to come up with. I hope it wasn't anyway. But still, all the same, I hope you can also understand the utility of having such a method, right? If I have a lot of arrays and I needed to compute the sum of them, instead of having this loop over and over and over again, once per array, it is much, much, much simpler and more straightforward to write a method and then use that method passing in each array that I care about. Let's make sure that it works, though. If we look at some of the ArraySum tests, you can see that, you know, it's passing in arrays of different lengths. So the sum of this one should obviously be 42. The sum of this one should be 30. Some of this one should be 20, etc. Let's run these tests and see how we're doing. All right, those all passed. Those all passed. So let's keep moving on. The next one on our list. So the past problem, we saw an example of using an array as an input parameter. For this next one, we're going to see an example of using an array as a return value. So let's go back to our methods and take a look at the filled array method. It wants us to return an array of given size filled with the provided value. So we want to create an array that has length, you know, of this length, and then go through and fill that entire array with this value. That's what we want to do. So let's go ahead and fix this first by creating the proper array size, right? Here we go. That takes care of creating the array. Now we actually have to use a loop again to go through the array, and you can use length here if you want to. That's totally fine, or you can get it from the array. That's totally fine. But we need to go through and set each position in the array to the value that's been coming in as a parameter. And then finally, you can see that at the end we return values, meaning that instead of just returning one number, we're returning a whole array of values. So you can see again, we have square brackets. That's your big clue, right? Be careful to put those square brackets by the type, not the name. Up here as well, you'll see the square brackets go by the type, not the name. So it's an integer array. That's how I would pronounce that. The return type of this method is also an integer array. But let's test it out. Let's see if we can run our tests and see if they pass the filled array tests that are provided. Looks like we do have a problem here with an array of length 2. And if I click on this test, you can see, oh, we've got a note here. There's a problem. Right? Let's read this test and see if we can't figure out what's happening. It says the length is 2, the value is 4. All right, so it calls the method with length 2, value of 4. It asserts that it's not null. It's asserting that the length should be equal to the value, but that's not true. The actual length of the array should be equal to the length. And the expected value should be the same value twice. There we go. So it was a typo in the test. Another example of the test not being correct. Let's try this again. Now that we've fixed the issue in our test, the test passes, and we're relatively confident that that method's working. The last couple of examples here are going to show us why, attempt to show us why our methods are so useful. We're going to reuse some of the methods that we've already done before to complete a couple of new methods. So the next one on our list is called ArrayMean. So if I go back to that file, you can see that, all right, we're not giving you any more starter code. We have to create our own methods now. We want to create a method called ArrayMean. It needs to be declared as public static. That's what we're doing for all of our methods for now. We'll change that in a little bit. The return type, so what should the return type be? So if I take the average of 1 and 2, that's probably going to be a double, right? So we need to, not just an integer, but a double. ArrayMean. Be careful about the name. If you don't get the name spelled exactly right, then the tests that are written won't be able to find the method. And then finally, the input is going to be an array of integers, it looks like. So we need to make sure that our parameters are specified accordingly. So I'll tell it that there's an integer array of values coming in. All right. We now need to do the actual task of averaging those values, and in order to take the average of a group of values, first thing we do is we sum it up and then we divide by how many of them there are. Well, we actually already wrote a method called ArraySum that takes in an array of values and returns the sum. So if I wanted to do that, right, I could simply call that method correct, and plug in the values. So if we think about what's happening here, this array is coming into this method, and I'm taking it and turning around and plugging it right into the other method. And once I get that sum back, I can just return the sum divided by values.length. And that should get me the average. Let's try it out. Let's see if it works. Okay. So for some of them it worked. I got 1, 2, 3, 4, -5, expected 1, 131, expected 1. So these are working. As soon as I get into decimal values, though, you see that we've got some problems. And if you ever run into this on your own, you should definitely try to expand these and click on one of these, and it'll actually tell you what happened. It expected 10.8, but it got 10. If I click on another one of these, we can see that it expected 0.5454 repeating, but got 0. That, to me, seems a lot like an integer division style of error. So sum is an int. This is also an int. So we need to, insert a double somewhere into this process. We can multiply by 1 here. Might help us out. Let's see if that fixes our problem. Oh, look at that. They all pass. That's fantastic. That's fantastic. So the nice thing here is that instead of grabbing this code up here and reusing it down here, we actually just called the method instead. This is the process of abstraction. This is really the value, right? Taking the mean requires taking the sum, so we can reuse that code that we've already done to help us accomplish the mean, and that makes this code look a lot simpler now. That makes this code a lot more easy to understand. All right. The last task on our to-do list is to create a Javadoc style comment. So we're going to go ahead and do that for not all of the methods. I'm just going to do it for the ArrayMean method up here. I think some of the other methods up top already have them anyway. The way to do this is to go to the line directly above the method, then type / ***, and hit return. It'll start to fill this out for you. So we now have to write a brief description. Computes the average of the given array. Here we'll specify what the parameter represents. There we go. And that is an example of a Javadoc comment. Now, Javadoc comments are used to help other programmers understand what your code does, and to show you what I mean by that. While this isn't something that you would normally do every time you write some code or create a program, if you ever find yourself in a situation where you've written some code and you genuinely want to share it with somebody else or share it with the world in general, you can actually easily take your Javadoc comments and have them transformed into a website that you can then publish to let people know how to use your code. And Eclipse can do that for you. The way that we do that is by going up to the project window and selecting Generate Javadoc. I'm going to do it for the Studio 5 project here. You can change the folder that it goes into if you want, but you just go ahead and click Finish. Sure. And this will just take a moment to do, probably not even that long. Once you're done, if you go back to the Package Explorer here, there's a new folder, or you might actually have to right-click and refresh to see it. But inside of this folder, if you look for the index page here, you can see, all right, I double-click this and it opens it up. And this actually looks much like the Java API documentation that I showed you in class. And if I click on the methods here, you can see that eventually we'll start to see descriptions of the methods that we've been working on in Studio today. And if I scroll down here to the very bottom where the ArrayMean method is, you can see that computes the average of the given array, values an integer array to be averaged. The average. Well, where did all that come from? Those are quite literally the comments that I wrote. These are the comments that I wrote. Eclipse has taken those Javadoc comments and turned them into something that is nicely formatted and able to be posted online so that people can use your cool code and read about it and use it in their own programs. So this is a very important thing to be able to know how to do. All right, that's going to wrap it up for the studio real quick, but let's take a look at the assignment before we wrap up the video for this week. So the assignment this week is actually based on the one from last week, so you're definitely going to want to have assignment 4 wrapped up first. In fact, the first part of it has you, I think, referring back to your work in assignment 4. So we're going to have you refactoring code, which basically means going back through and adding in methods. So, I spoke about this in class. Anywhere that you notice some repetitive kinds of behavior, things like that, we can use methods to abstract that behavior out and give it a name and do it that way. And so that's what we're asking you to do. Your code's going to do a lot of the same stuff that it did last week. We are going to ask you to add in a few additional things this time around, but for the most part it'll do the same thing that it did last week, and it's just going to be using methods to help organize and explain the behaviors that are going on instead of cramming everything into the main method. We have provided you unit tests, and we will be providing you unit tests for homework assignments from now on. This is a very valuable tool, like I said, that you can use to help you determine if your code is working properly or not. And, of course, passing the unit tests is a very big thing that we look for when submitting the assignments. But please know that the unit tests don't mean that your code is bulletproof or that it's going to work in every situation. Consider that when you take a test for a class, even if you get a 100 on that test, you get every single question right, that doesn't mean that you know everything about the topics that were on that test. That just means that you know about the questions that were on that specific test. So there still could be plenty of other things that you don't know or that you have incorrect ideas about that just weren't tested for. The same thing's true for your computer code. You always have to assume that there's going to be some issues or other problems with your code that you just haven't thought of yet, you haven't found yet. And that's okay, right? That's all right. All right, that's going to go ahead and wrap it up for this week. I hope you all have a great weekend, and I will see you back in class next week.